first we're going to start by grinding this up so that we can press a pellet with it. This has been previously dried, so it's got to be, all the water needs to be removed from the food first. Okay, second try. Turn the balance. It's right-handed this time. I don't know how well I'll be able to do this. 1 gram. Does not need to be exactly a gram, as long as when we are done pressing the pellet, we know exactly how much that pellet weighs, and it should be very close to a gram. That is close enough for me. It's a little over, but I know that the pellet, when I press it, we're going to lose a little bit in the transfer anyhow. Static defies me. That should do it. Press down firmly. Okay. Leave that on there. Turn it. And now we are weighing our pellet. Guess I didn't lose too much. That is 1.07 grams. So that is the number that we will write down. 1.08 for the weight that we are placing in here. Our pellet. Transfer to the crucible. Is that all within frame there?
Mm-hmm.
We're going to combust here. And where that is going to hang is by this rod here. This rod also doubles as an electrode holder. So we'll check these little holes here for remnants of old ignition wire. And once that is cleaned up, I'm going to pull a fresh piece of wire off of here. Looks like people have been messing this up. Just cut. To cut a defined length, the spool on which it's held actually will allow you to that measurement. 10 centimeters, which is the length of this piece here. 10 centimeters, and cut that. A 10 centimeter piece of wire is going to be then suspended by these 2 electrodes. Just a tiny little hole there.
Can I zoom in on this? Or is that too fine? It says change the battery pack.
Whoop. Okay, good time to stop. I'll go get the plug in, and if it's not quite dead yet, is it sort of zoom in? This might be difficult. Actually, food stuff, so we're going to combust. Crucible goes in this holder. And the wire should be brought inside the crucible, just over the foodstuffs, so that when it ignites, it ignites the foodstuffs as well. Also want to be very sure that this electrode doesn't touch either side of the crucible. It will ground it out, and it will not fire.
Mm-hmm.
Okay, so now this guy is going to go in here. Check first if this is nice and clean. Press it down firmly. Ensure that this is open so that the air can escape. Press that down, and now to secure this, we use this large metal ring. is just going to be secured hand tight. By hand tight, we're talking as tight as you can get it with your hands. To be honest. Now, you can keep it rolling. This is a holder. Use this then to carry it around the room, ensuring that it stays upright. Okay, so just prepared. And to utilize this, we need to make sure the valve is closed. This is the release valve that needs to be closed. And this second post right here, not the electrical posts, this post is where this brass adapter slides on. There's a hole inside of here, separated by two ring gaskets, ring seals, that sit around another complementary hole that kind of bridles this one. So when the air is delivered from here, it will enter into this hole, and there's a one-way valve in here to ensure it doesn't come back the other way. So we'll press that down on there. There shouldn't be any upward pressure, so it's not unsafe to leave it unrestrained. I like to keep my hand on it just so that I feel better about it. One is the tank itself that will pressurize the whole system. This valve, this controls the amount of pressure that is delivered to the bomb. And then this is a release that you'll need to use to depressurize the system after you've charged the bomb. So what we are going to do first is open the tank. You'll see this indicator can be up, it can be on throughout the day. That indicate as long as that is turned off at the end of the day. This indicates how much pressure is being delivered from the tank or is contained in the tank. Now this valve is the one, or this dial is the one that we are going to want to watch to know how much pressure we're delivering to the bomb. And the way we're going to work that, I'm going to hold that valve in place, and I'm going to open this very slowly. Watch this valve, this dial. Watch that until it gets up 30. That's as high as it's going to go. Okay. Close that valve. That relieves the excessive pressure that's pushing in there, but what it doesn't do is relieve the pressure that's throughout the system. And what I want to do before I remove this from the bomb is release this valve here, which will relieve the pressure from the line itself, but still leave pressure in the bomb. Once it's pressurized, we're going to relieve this. Remove slowly. Make sure the seals are still in there. And now pressurized, we'll take this back to the bench. Okay, so to load the bomb, back to our table. First we're going to fill this chamber with 2 liters of water. What we are measuring in bomb calorimetry is the temperature change of this water. So it's essentially that it'd be actually 2 liters for us to do our calculations. There's 2 liters of distilled water. This tank. We can do this either way. Let's place this in here first. No, let's not do it that way. Let's do it this way. The reason for that will be apparent once we try to load the lid. Into that, we then lower our bomb. And inspect for leaks. So now we're just waiting another 10 seconds. What I've done is replace the seal, repressurize the chamber with oxygen, and now inspecting it underwater to make sure that we do not have another air leak. There are 2 electrodes that are integrated into the calorimeter's thermal jacket. These 2 electrodes, there's not a negative or a positive, they're just relative to each other. So those can go into either of these 2 holes in the top of the machine. You might push a little air bubble out here, but this is not continuous with the inside of the chamber, so it's not to be worried about. Those 2 electrodes are secure. And these 2 things need to straddle the bottom inside of the jacket. The impeller is the larger of the 2 that project in there, and so you will see an accompanying larger side next to the bottom calorimeter itself. That is where the impeller goes, and it also needs to be oriented with this motor. Set the lid on there. Check that the impeller is not impeded, that it's rotating smoothly. And then we will connect the motor and the impeller by a special rubber band. Turn this guy on. The thermometer, when you turn it on, has an automatic clock. So it will just start itself. So time 0 is just the time that we turned it on, and what we're going to do is pick a time once this temperature is stabilized to ignite what's inside the bomb. Can you still see this guy there? So while that is stabilizing, we're going to watch the temperature for a few minutes. Hook this up. The bomb itself can be hooked up 2 different ways, depending on the length of the fuse. The fuse that we cut was 10 centimeters long, and so that will mean placing one of these electrodes to that 10 centimeter connection. We push this button just once and watch for the red light. If this successfully ignites or burns the wire, we will see this red light come on and off, and then we will watch the temperature. Right now we're at 21.346, so let's ignite the unit. A little flash of red light is all we expect to see. Within a minute, no more than 2 minutes, the temperature should begin to rise. If it does not, then it means your run was unsuccessful, in which case. All right. So once it's stabilized, we're going to turn the thermometer and the impeller motor off. Remove the band from the impeller motor. Remove the lid. Disassemble it opposite of how we placed it together. Remove these 2 electrodes. Remove the bomb. The chamber. And then the final important crucial step is the rate at which we allow the pressure to escape the bomb. So this release valve, we don't want to just open quickly. Tease it open slowly. Allow the air to escape at a reasonable rate. Pour this bit of water off the top. Just to make sure we're empty, and disassemble the whole thing. We're still recording. Hopefully this worked well. So I'm about to reveal the inside. Should not ever need to use tools to remove this. It will be tight, but if we're persistent, twist and pull, it will come out. And there we are. So you can see our crucible. Food is quite well evaporated. We have a little bit of the ignition wire left on this electrode, so if we want to calibrate for that, we can also make adjustments for how much is left. At the very least, we should remove that last little bit of electrode from each of these sides and clean the condensation from the inside of the machine before using it again.